Got some stoichiometry here, one of the most common chemical reactions on Earth. I don't know about that, but maybe in living things this might be true. This is cellular respiration, by the way. What mass of carbon dioxide forms in the reaction of? All right, so we're given quantities of both reactants, so we'll do the stoic with both of them. We're given quantities of oxygen and quantities of glucose. The molar mass of glucose, carbon is 12.01. There's 6 of them. 72.06 grams per mole for carbon. Hydrogen is 1.008. There's 12 of them. It's 12.096 grams per mole. And oxygen is 16.00. 6 of them. It's like 92, I think. Oh, sorry, 96 grams per mole. Right, yep, so there's glucose. Let's add them up. Molar mass of glucose is 180.156, just grams per mole. All right, let's do the same thing for oxygen. Oxygen is just O2. Molar mass is just 32.00 grams per mole because oxygen is 16 and times 2 is 32. All right, so we got those out of the way. We can do our stoic. It wants to know carbon dioxide, mass of carbon dioxide, so we'll do that one as well because we're doing all the molar masses, so just get them out of the way. All right, carbon again is 12.01, and then oxygen is 32.00 because there's 2 of them. We just did that. All right, let's add them up. Let me go this way. 44.01 grams per mole is the carbon dioxide, CO2, molar mass. All right, so now we can just worry about the stoichiometry. We don't really, well, we'll need our calculators, but okay, let's 25 grams of glucose. Let's do it. Let's do this in a slightly different shade. All right, 25.0 grams of C6 H12O6. Convert that to moles. All right, so we just did all that. The molar mass was 180.156 grams in 1 mole of that stuff. Glucose. All right, let's cancel these units out. Gone. Now let's turn that into carbon dioxide using the mole ratio. All right, so there's 1 mole of glucose to every 6 moles of carbon dioxide. All right, so there's 1 mole of glucose to 6 moles of carbon dioxide. 6 moles of carbon dioxide, and cancel out those units. And then finally, we can convert that into moles of or grams of carbon dioxide. All right, so we have right now moles of carbon dioxide, and let's turn that into grams. And we found that earlier is 44.01 right up here. .01 grams of carbon dioxide in 1 mole of carbon dioxide. Oh, boom, let's punch these numbers in. 25 divided by 180.156 times 6 times 44.01. 36.64 grams of carbon dioxide. I'm just going to leave that there for now. Not our final answer yet. So oxygen, we're starting with 40 grams of oxygen. It's given in the problem. Again, I'll pick a slightly different shade here. 40 grams of O2. Convert that to moles. Moles we can convert to anything else. So that's why we need to convert that to moles. So it's 32.0 grams of O2. We did that up there. Got all the molar masses first. Got them out of the way. All right, that's in 1 mole of O2. All right, cancel these units are gone, and now we can use the mole ratios to convert moles of O2 to moles of CO2. All right, I believe it's 6 to 6 or 1 to 1. Yep, 6 for every 6 moles of oxygen, we're going to produce 6 moles of carbon dioxide. So we can reduce that to 1 to 1, or I'll just write 6 to 6 for now. All right, but I'm going to cancel out these units, keep track of those. And then our final step is to convert to the desired unit. Now that we have the desired substance, which is carbon dioxide, we can turn that into grams using the same conversion factor we used above. Okay, cancel. Calculator. 40 divided by 32 times 44.01. It's 55.01 grams of CO2. All right, so now we know which one is the limiting reagent, and that's going to be the one that leads to the fewer amount of product. So glucose is the limiting reagent. This here is the theoretical yield. Okay, and then now we can trim it down to 3 sig figs because anyway, that's what's the question here. That's our final answer, because it's asking us what is the mass of carbon dioxide, and that is it. That is it. And by the way, this is you're gonna have leftover O2, so that's known as your excess reagent.